Gracias. Bueno, gracias por venir. Thank you for coming. Hopefully this will hold. Okay. So I guess this talk is a bit about what I think is a common misconception amongst technologists, including some people who have had some contact with Smalltalk. And I think there's still a misconception that Smalltalk is suitable or adequate for small projects, or even adequate only as an educational tool. So I'm hoping to at least make a little dent on that idea with this presentation by telling you a little bit about what we do with Smalltalk in JP Morgan, and in particular about a system which is called Capital, which is written in Smalltalk. So that's what I'm here to talk to you about. Before we get into the Smalltalk side of things, I want to give you a bit of context about sort of business environment where we work in JP Morgan, where the Smalltalk technology fits inside the organization. So JP Morgan is a bank, right? Maybe some people know about that, but JP Morgan is a bank. It's not just any bank, right? It's a very big bank. How big, you say, right? It's half of the American households have some kind of relationship with JP Morgan, right? That's very big. Half of the American households, right? We serve half of them. 80% of the Fortune 500 companies do business with JP Morgan. 80%. And 60% of the funds of the entire world deal with JP Morgan. Okay? 60%. Some big numbers, right? We have, JP Morgan is a global bank. The business is pretty big, right? Almost $100 billion of revenue annually. Okay? 2.4 trillion in assets. And I think what for me is the biggest kind of, or the most interesting number in there is 240 employees around the world, right? That's pretty big. Another, I think, very interesting statistic is that half of all of the e-commerce transactions that happen in the US happen through JP Morgan, right? Half of all the e-commerce transactions, that's Apple, Amazon, Facebook, okay? Half of the transactions. Every year, we process $6 trillion of payments. Every day, sorry, not every year, every day. And in order to achieve that safely and reliably, the bank spends $8 billion a year in technology. Okay? $8 billion. This is probably something common for most businesses, but in particular in the global financial markets, this is a bit more, I guess, the scale is a bit bigger. The technology and the technologists are expected to deliver systems which are faster, simpler, more flexible, continuously, right? Market evolves, competition is fierce. This has to happen constantly. To give a bit of a comparison, right, in terms of how big JP Morgan is, I mentioned there's 240,000 employees, but out of those 240,000, 40,000 are technologists, okay? You can compare that with, for example, Google, which is 55,000. It's almost the size of Google in terms of the technology organization, right? So this is basically what's happening here is you have a huge technology company embedded within a bank, right? It's a huge company. It's a huge software company embedded inside the bank. In terms of complexity of that environment, I'll just mention a few things. There are 7,000 applications in the bank. Okay, 7,000 applications. There are 32 data centers around the world, 32 of them, with about 66,000 machines in those data centers, right? Now, with that in mind, right, that kind of scale, Capital, which is the Smalltalk system, was born about 20 years ago, just over 20 years ago, to support, in particular, a part of the business that JP Morgan does, which is derivatives trading. Okay, there are financial instruments called derivatives. You might have heard of them. And the idea of the system was to allow the derivatives business to be able to come up with new products, design them, and be able to go from the idea of a financial product, a new one, completely brand new, something that didn't exist before, and be able to market it, which means be able to calculate the value of that financial instrument or transaction. But not only that, we also need to be able to manage that transaction throughout its life cycle, which can take anywhere from a few days to many years. Okay, that transaction will be alive for many years. The system has to be able to manage that. So about 20 years ago, this business wanted to come up with a system to support that kind of functionality, and there were many attributes which were identified at the time as necessary to make that a success, right? Things that are quite common in a lot of systems, but here they were critical, right? So productivity in terms of being able to go from the idea that the business had to something that the bank could actually transact was key. That had to be done very quickly because the competition would be doing the same thing very quickly, so we had to be first, basically. Scalability in terms of if a particular financial product became very popular, we had to be able to do not just one of them, but thousands of them, without needing to spend more time to allow the system to cope with that, right? So there had to be some very well thought out scalability attributes in the system that allowed for that to happen. It could be, I make one transaction and that's it, I'm done. I need to be able to do thousands of them without problems. The system had to be very flexible because we're talking about completely new ideas that someone from a business just comes up with, right? This is not someone saying, okay, this is what I need, I'm going to write it down for you, I'm going to give it to you, you can go away for 3 months and come back with a solution, right? It had to be a very exploratory kind of environment, or an environment that allowed for prototypes to be built very, very quickly for the traders to be able to decide, yes, this is what I want, this works, we can do this, we can market it. So it needed that kind of flexibility. And portability was also very important, because it was very clear at the time that financial derivatives were only going to grow, and technology was going to be changing throughout all of that time. So the system had to support the growth of the business and the evolution of technology and technology platforms. And we couldn't risk the system not being able to run on the latest and greatest hardware just because we had chosen X and Y technology, right? It had to be portable to different technologies. So all of these things were things people thought were critical. So at the time, Smalltalk was the only thing that fit the bill. right? This was 20 years ago. They looked at a bunch of choices and said, yeah, definitely Smalltalk has the right attributes to do this. And over time, they proved to be correct, right? Just to give you an example, Capital over these 20 years has run on a variety of hardware platforms, everything from very large compute nodes to the very inexpensive blade technology that we use today. And it's been migrated Solaris, Windows, Linux very, very easily compared to what would have been the case with different technology. For example, if I recall correctly, the migration from from these big Solaris boxes to be able to run in a blade took something like 6 months. Okay, that's the sort of time scale we're talking about. So a bit more history about Capital. So over these 20 years, about 400 developers have contributed to Capital, right? 400 people from all over the world, and not just computer scientists and engineers, right? We've had plenty of mathematicians, physicists, chemical engineers. There's been a few musicians which were technically inclined. Think of any country and background, and there's probably someone who worked in Capital who was from that country or had that background. It was very, very diverse, this group. And the effect of time and the pace of change and the sometimes very strict requirements that the global financial markets put on systems could have easily made Capital obsolete, right? But that didn't happen, right? And I don't think that's a coincidence. I think that is because of the technology chosen and the architecture that was built on top of it, right? The system has clearly stood the test of time, right? So how is the system, I guess, distributed, right? I mentioned JP Morgan is a global bank, so we do business all over the world, and Capital supports that business all over the world. There are 12 instances in total of the system. We cover places like London, New York, and a few places in Asia as well, Tokyo, Hong Kong. And we work on a single code base, right? The system is a single code base, and we do continuous integration and deployment. To I guess, give you a bit of a flavor for what it's the rhythm of changes that we need to deal with. We have a release of the system every 3 weeks, okay, globally. So we deploy all of the code every 3 weeks globally. But that's not all. That's kind of our planned release, our large releases, I guess you would call it, global release. But we deploy every week as well to every single instance any urgent or critical patches that we need, right? Every week. So constant pace of change, right? It's not a system where, you know, we'll plan a release which will go out in 6 months, right? And we'll have 6 months to test it. It's not that kind of environment, right? It's very fast-paced. And the fact that it runs globally means that there is never a quiet downtime, right? There is a trader every hour of the day somewhere that needs to do something, okay? All the time. There's never a quiet time. The system runs 24/7. So, what does the system do? I guess it's quite hard to explain what the system does in such a short time, but I kind of gave you an idea. So it basically needs to price or calculate the value of financial transactions, right? That can be, financial transactions can be very simple, which means you can calculate the value in a few seconds, or they can be very complex and can take minutes sometimes, okay, to calculate one price, one value. So in Capital, we need to deal with millions of those transactions, okay? Not a few hundred, not a few thousand, a few million transactions. So in order to do that, and to be able to take all these transactions through all the life cycle, we need a lot of computational power. Okay, we need to use a very big compute farm. In JP Morgan, I mentioned there were about 66,000 computers, okay, in our 32 data centers. So Capital uses the third largest compute farm within that, okay? We occupy the third place in terms of number of machines we use. Our Smalltalk images run on thousands of machines, okay? Taking advantage of distributed Smalltalk technology, okay? It's all written in Smalltalk. And also making very good use of the excellent gemstone technology, okay? It's all Smalltalk driven. I mentioned GPUs there as well. We also take advantage of GPUs. That kind of, I wrote that as we run images on GPUs. That's not really true, right? We don't run images on GPUs. But we do use GPUs for some of the things we do that can be accelerated. In terms of how much data we move across a network, we move 1.2 petabytes a week. That's a lot, okay? If I did the math correctly,
what's a petabyte?
So it's more than a terabyte, a lot more. So if I did the math correctly, 1 petabyte is enough to store the DNA of the entire population of the US and clone them twice. Okay? That's a lot of data. We move that in a week. Okay? Sorry, there's a few more interesting things. So the system generates 100,000 feeds, okay, every day. 100,000 globally, okay, that get distributed inside the bank to many different groups and external systems, okay? 100,000. How many are we? You probably, by now, you probably think, oh, it must be thousands of developers, right, working on this, supporting it. No, just 90 of us. So the development team is 90 people. Yeah, we're a global team, so we're distributed amongst the different sites where we have traders. We work in Tokyo, Hong Kong, Mumbai for Asia, New York, London, Glasgow, which is in Scotland, if everyone's wondering. And now we're building a team in Buenos Aires. I guess in my summary is we invest in and love Smalltalk technology. And best of all, we're hiring. So if anyone is interested or wants to find out more, I'll be around the conference. Just come by for a chat. Happy to discuss whatever you want to know about Capital. Thank you. Hernandez, is there time for questions?
Yes, 10 minutes.
Any questions? Yes.
A couple of questions. You just mentioned on how many servers Capital runs.
Yeah.
Are all user access through some form of web user interface or something like that? Or people can read on their machines as well?
So we run a variety of platforms. So the system would run in things like Windows. It's not that common anymore. So these days it's basically Linux based. And it's client, heavy client. It's a Smalltalk image. It's a client. There's no web.
Okay. And how large is the code base?
How large is the code base? I didn't include that on purpose because I don't like those stats. I think they're a bit misleading. Like number of lines of code, number of classes. I didn't include that. I can't remember, but
Big, I guess.
it's what?
Big.
Yes. Yes. Yep.
Well, capital is like the flagship, one of the flagship products for Smalltalk, and then you want to show us you mentioned capital. In this 20 years, I know maybe you started with big car focus, Smalltalk, and then you specialize in the derivative area. But in the middle of those 20 years, is it true or actually did you try to, JP Morgan, try to switch to a new technology? Because, there have been
Yes.
rumors and maybe they try and fail actually.
Yes.
So,
Yes. The answer is yes.
Nice.
Could you repeat the question?
Oh, yeah, sure. So the answer was, did someone try to change the technology for something else, perhaps? And yeah, there have been attempts. Yes. There's always attempts. Everyone thinks they can easily get rid of a Smalltalk system, right? It's part of that misconception, I think. It must be a toy system, right? If it's written in Smalltalk, I can do that in a night, right? Yeah, right. Yep, Imam?
Could you tell us how many gemstones repository are you using, and if they are all connected or they work standalone?
It's 12 of them, so they're independent.
And they're independent?
Yep. The code base is the same, but the objects that are in the repositories are different.
And how big is the
There's reasons for that as well. There's things like certain countries, the regulators wouldn't allow you to have their objects representing their transactions hosted somewhere else, for example, in New York. You couldn't do that always, even if you wanted to, right? If you thought, oh, this is great, I'll just have it all in New York, right? You can't always do that.
And how big is the biggest repository?
So,
In terms of objects and files?
about 600 gigabytes, if I recall correctly, 600 to 800, somewhere along those lines, depending which day of the week you look at it. Yeah. It's pretty big. We run it over the weekend. But yeah, just on 64 is pretty quick now. So. Any other questions?
Yes. Are you aware of any other Smalltalk system used in JP Morgan?
Smalltalk. So,
Or is this the only one?
I'm not aware of another one. No. In JP Morgan. I would say I wouldn't necessarily call Capital a system. It's more like a platform, I would say. There are many systems, I think, built inside Capital using the same sort of platform, but we call it all Capital. More than a system, I would call it a platform, but we're the only one. We're the only team inside JP Morgan working with Smalltalk, as far as I'm aware. I mean, there are 40,000 technologists, right? I don't know them all. There might be a group somewhere hidden that's secretly working in Smalltalk. Could happen. Yep.
So, a quick one. If these platforms isn't time, why do you think that JP Morgan is leaning towards giving more systems this technology as a tool that is good for business version?
That's a tricky question. It's a good one. You probably know the answer, though. I'll tell you anyway. So it has nothing to do with technology usually, right? That type of decision. So it doesn't matter if the technology is good or not.
Well, I mean, if this technology is closely related to the profit or the business, right? That's my question.
Yeah, but sometimes there are other things you want to do, right? I mentioned there's 7,000 applications, for example. That's quite complex. Sometimes you need to reduce the complexity by some means, right? So there's many reasons. It's not just the fact that technology is good or not. Yep.
Did you ever have any bug or any current system that was presented in the market somehow? Like 2 years ago, there was a problem with semi-related to doing frequency trading, or do you ever experience something like that? I don't like to understand.
I guess, yeah, oh, sorry. So I believe your question was there ever a bug, an instance of where there was a bug that impacted financial markets, I guess, that's what you're saying? No, not in the way that you described, like that kind of, because this system is not, I guess you would say, actively connected to the markets in that way. So it doesn't make decisions for people and goes away and trades something. That's not what the system does, so it wouldn't have that kind of impact. There could be things that would have an impact to the firm, right? For example, if the system fails to produce reports that are used for certain regulations that require you to report certain things, if you don't do that, you can get fined, for example. So there could be that kind of impact if there's a bug in the system where you fail to produce what you need for a regulator, right? Yeah, Juan?
You said that capital allows JP Morgan to define new financial products and value them and trade them.
Yep.
And they trade them with people outside JP Morgan, I guess.
Yeah.
So,
Or internally, it could be internal in some cases, yeah.
For a minute, let's assume it's with someone outside. Those people and you need to agree on how to value the financial products, right?
No,
No?
not necessarily.
Okay.
It's like I sell a car to you. I might, yeah.
You have no relation to the price.
So we don't have to agree on the price. We don't necessarily have to, right? If it's worth something to you and that's the price I'm selling it for, then you'll buy it, right? It's the same as any other product.
So the value is internal information.
Yeah.
So a value like Luciano said would mean value something wrongly and therefore make a purchase or a sale that was not convenient. Right? Something like that.
I'm not sure I understand.
I try to understand the impact of possible bugs.
Oh, so if we miscalculate a value of something, for example?
Yeah, you buy or sell at the wrong
Yeah.
price because the value was...
Yeah, that could be bad. That could be bad, yeah. Yeah. And there's a lot of people who spend a lot of time
trying to do that.
and making sure that those values are correct as far as they can, right? There's many control groups that would ensure that things don't, are not out of control, right? Yeah. There's financial regulators, right? Yeah.
Thank you.
Thank you.